Welcome to the video all about the tropical monsoon, ladies and gents. This year, the module booklet that I have in front of me, it is on page 45, but obviously depending on when you're watching this, the page numbers might be slightly different, but it should have the title anyway. So, the tropical monsoon. Just as a little bit of introduction to you, your syllabus requires us to teach you about a tropical climate, meaning the climate of somewhere between the tropics, which is why I've put this map up on the screen. There are actually quite a few different tropical climates, but we choose this one because it is about as opposite to the UK climate as it is possible to be. And seeing as you have to learn the UK climate, the cool western temperate maritime climate, and you therefore have to revise that one, we thought we would try and make your life as straightforward as possible by making this one as opposite. So the tropical monsoon affects places in Southeast Asia, which is the bit of the world that this map is focusing on. But our lesson today is very much going to focus on the Indian subcontinent because the tropical monsoon is most emphasised on India. What do you need notes on? Well, really there are three things. What is the climate like and how is it different to the UK? That's quite straightforward. The middle bullet point is the tricky one. This is the explanation. I'm not going to be really teaching you anything new, to be honest, but we're going to be putting together knowledge that you already have about the ITCZ and convection in a new way. So it's not new information, but it is, it's not the most straightforward thing, but we'll persevere, don't worry. And then finally, just like we had to for the UK, just a brief overview of what this climate does to the people and things that have to live in it. Okay, without further ado, let's crack on. Okay, that's how it's different to the UK. We spent quite a considerable time focusing on the fact that the weather in the UK changes a lot. What the weather is like when you get out of bed in the morning could be quite different to what it's like by lunchtime. The following day could be completely different once again. That's normal for us. That's not the case for India and places that experience the tropical monsoon. In fact, you would expect the weather to be the same for days and days or weeks and weeks at a time. Also, the seasons are very, very different to one another. And in fact, the term monsoon, this is written in your module booklet, the term monsoon comes from an Arabic word meaning season. The monsoon is all about the seasons, ladies and gents, okay? They are very different to each other. In fact, let me just jump ahead. You've got incredible variations, whereas in the UK, although we do have seasons, we definitely do, they are not radically different to each other. It could rain in January, it could rain in July. They're different, but they sort of merge into each other, whereas in the tropical monsoon, it is absolutely characterised by very different seasons. All right, so that is the first thing to know. It's also very predictable. We spent a little bit of time with the cool western temperate maritime talking about how hard it is to plan in advance. So you may well have experienced this in your normal everyday lives where you've planned to do something and then the weather has completely ruined your plans. Might be a sporting fixture or a family barbecue or a trip to the beach or whatever. Whereas pre-climate change, and of course climate change has ruined everything, but pre-climate change you could get these maps where you could predict the date that it would start raining each year. That's crazy, isn't it, compared to the UK? So it's a very, very different climate type to the UK. What is it like? Well, it's very seasonal. We've talked about that already. But the first thing I need to really emphasise to you, lots of people learn that the tropical monsoon has two seasons. The wet season, which is from June to September, as you can see from the graph, and the dry season, which is the rest of the year. At A level, we would really like you to learn 3 seasons, okay? Notice that from March to May, there is quite a sharp increase in the average temperature. So we have the wet season from June to September. From October to February, we have the hot, dry season. From March to May, we have the very hot, dry season. Okay, so actually at A level, we'd like you to learn 3 seasons, please. Not every year, but some years, in the March, April, May bit, it gets so hot that plastic objects begin to melt, which is bonkers, isn't it? But 3 seasons, please. Do you need to learn to draw a climate graph like that? No, you could by all means chuck it into an essay, but yeah, just understanding that it's a very seasonal climate will be perfect. But the explanation, ladies and gents. Okay, so the explanation is back to our good old friend, the Intertropical Convergence Zone. The ITCZ is the low pressure area where the Hadley cells meet. It moves with the seasons because, as we now know, the sun is not directly overhead the same part of the planet all year round. We have the solstices and the equinoxes, and I'm not going to revise all that with you now because I've done that in a previous video, and if you still need a little bit of help with that, why don't you go back and re-watch one of those videos. What I need you to accept, or hopefully even better, understand, is that the ITCZ moves north in our summer, the Northern Hemisphere summer, and it moves south in our winter, which is why the summers are the opposite in the Southern Hemisphere, because it completely depends on which half of the planet is receiving the solar radiation. Okay, now let's really focus this time on India. Okay, so this is the part of the world that receives the tropical monsoon climate, and it is very much emphasised in the Indian subcontinent. Notice here in our summer, the ITCZ lies over northern India, whereas in the winter, the ITCZ has moved south. That shift in the ITCZ explains almost everything about this climate. Okay, now this animation is absolutely brilliant for kind of refreshing your memory, but it will only work, as far as I can tell, in Internet Explorer. I cannot get it working in Google Chrome at all. Sometimes it works in Edge, sometimes it doesn't. So that's a little bit frustrating. If you can get it to work, brilliant. If not, although it's slightly frustrating, I have found this YouTube video created by somebody who uses this animation. So although it's not perfect, it's better than not having it at all. And it just reminds you of how the ITCZ relates to the Hadley cells and where it moves and all of that sort of thing. Okay, so it's all about the movement of the ITCZ. Okay, now I've got my own terrible version of this to show you in a minute. Here is India, here is Sri Lanka, here we've got the Himalayas. Nice little synoptic link, because of course the Himalayas are created by tectonic processes. We've got a link here between climate and tectonics. But anyway, this is the summer, okay, notice. What we know about the summer is that the ITCZ is over northern India. We also know that the ITCZ is a band of low pressure. We know that in low pressure the air is rising, and that means the air has got to be replaced, because if you've got rising air and nothing comes in to replace it, you're going to have a vacuum. That's not good. That means, ladies and gents, that the wind will always blow towards low pressure. Winds always blow from high to low. You can remember that little thing. Winds always blow from high to low. So look, when the ITCZ is over northern India, the wind is going to be blowing this way. The wind is coming from the Indian Ocean. It's going to be picking up lots of water vapour. As that wind passes over India, you are going to have the rainy season. All right? Here, everything has shifted. The ITCZ is now south of India, purely because the sun is no longer directly overhead the northern hemisphere, it's now directly overhead the southern hemisphere. Winds always blow from high to low. If your low pressure is now down here, the wind is going to completely reverse direction. The wind is now coming from the largest landmass on Earth. It is not going to be picking up any water vapour because it's coming from land. So when the wind is coming from this direction, it's the dry season. Okay, so it's about the shifting of the ITCZ and the changing of the wind direction. Wind always brings the characteristics of where it's come from. Here, it's going to pick up lots of water vapour. Here, it isn't. And you can even show off a little bit more. We've got the Himalayas here. That is the biggest mountain range, the tallest mountain range on planet Earth. Even if the wind did have moisture in it here, by the time the wind has gone up and over the Himalaya mountains, India would be in a rain shadow anyway. So it's there are two reasons why the air is completely dry. First of all, it comes from a huge area of land, and secondly, it passes over the Himalaya mountains. That's the rainy season, that's the dry season. Now, you're not going to like my diagram, it's one of the worst I've ever drawn, but I did try to warn you. So the black line is meant to be India and Sri Lanka, the red line is meant to be the ITCZ, and the green line is meant to be the winds. Basically, it's quite a good diagram to be able to draw, and I'm sure you will do a significantly better job than I have done. I'm so embarrassed of those. I'm just trying to prove that a simplified version of that conveys quite a lot of knowledge and understanding, particularly if you then annotated it. So it's a really good thing to chuck into an essay if you can. Okay, so ITCZ moves, wind changes direction, wind brings the characteristics of where it's come from, and you get a completely different set of weather conditions. Okay, so here is just a topographical map so you can see the Himalayan arc, which is being created by the Indian continent being pushed into Asia. So this is an area of fold mountains that we learned in tectonics, and it's just to prove to you that that definitely would create a rain shadow effect. Okay, so that's that. Just a couple of things. Why are the winds not going in straight lines? Well, that's back to our good old friend the Coriolis Effect, which of course we know means that things are not able to travel in straight lines because they are travelling from the equator, which is spinning very fast, and other places which are not spinning quite so quickly. So that's Coriolis. You don't need to mention that, I'm just explaining that to you for your own understanding. Okay, now the second part, differential heating, and you might have seen that phrase earlier on and gone, oh, I'm not sure, but you do know this, I promise you do. We have talked about the specific heat capacity of water and how it takes a huge amount of energy to warm water up, whereas it doesn't take a lot of energy at all to warm land up. So what we mean by differential heating is that land and sea heats up at different speeds. It's just a posh way of saying that. Water warms up and cools down very, very slowly. Land heats up and cools down much more quickly. Okay, so notice that India is a triangular shape. Now the other thing, of course, that's going to happen as the ITCZ moves is that the sun is going to pass over India, isn't it? So the sun is going to be heating up the land of India quite a lot because land heats up and cools down quite quickly. And the triangular shape of India kind of really exaggerates that. So the land gets hotter and hotter and hotter and hotter, and it leads to a process called convection. Now, convection is a process we talk about in geography quite a lot, and it's very simple. Hot things rise, cool things sink. So if you can imagine this landmass getting very, very, very hot, the air is going to begin to rise because of convection. Rising air has got to be replaced. We've already mentioned that today. So it's going to suck air in from the surrounding areas, which is of course ocean, and you're going to suck in wet air, which is going to add to your rain in the wet season. So convectional rain is the one that we've talked about the least because of the three types of rainfall that are possible, it's the one that we do not really get in the UK. We get frontal rain, where you get warm and cold air meeting and the warm air is forced to rise. We get relief rainfall, where air is forced to rise over hills and mountains, but we don't often get convectional because what you need for convectional rain is heat. We just don't get a huge amount of that in the UK. Now, I have done my best to explain that to you, but this BBC Learning Zone clip is fabulous, and it's explained so much better than I am capable of. So I would highly recommend that you follow that link and watch that video. It's not very long, maybe, I'm guessing here, maybe 5 minutes, but it will explain this differential heating, convection type stuff to you. All right. Then on page 46 of this year's module, we're not going to dwell on this for a huge amount of time, but when we were talking about the UK climate, we were saying, yes, the whole of the UK has the same climate type, but there are regional variations, and we were talking about how the further north you go, it will begin to get slightly cooler because you're going further away from the equator. We talked about how there'll be variations between coastal and inland places and all of those kinds of things. Well, it's just the same for India. Not everywhere in India is going to have exactly the same experience of the tropical monsoon. And on page 46, you've got 3 very, very different climate graphs. Mangalore, or Mangalore, I'm not quite sure how I'm supposed to pronounce that, has your kind of typical, if you like, monsoon climate. But because it's coastal, the temperatures don't vary very much because, of course, we say how coastlines have like a regulating impact on temperature because of this specific heat capacity of water that we've talked about. They don't get too hot and they don't get too cool. So that explains why Mangalore's temperature line is relatively flat. Delhi, which is right up in the north of India, receives much less rainfall and has a much bigger difference between temperature. Well, I've explained the temperature bit because it's a long way inland. It doesn't have that insulating effect of the sea. It gets hot and it gets much cooler. Why does it not get much rain? Well, let's think about this. Here we are. So Delhi, here it is. By the time the monsoon rains have got all the way to Delhi, most of their rain has already fallen out of the sky. There's hardly any rain left by the time you get to this area here. It's just an issue of distance. And then the third graph that you have on page 46 is for Cherrapunji. Now, Cherrapunji is sort of around here. It is the wettest place on planet Earth, and I've got a photo to show that to you in a minute. Why is it so wet in Cherrapunji? Well, we've already said the Himalayas are here. This is going to be affected by the phenomenon of relief rainfall. As the air starts to rise up over the Himalayas, every last little drop of water vapour is going to be squeezed out and condensed, and Cherrapunji therefore receives this huge deluge. So that's where it is. There we are, the wettest place on planet Earth, Cherrapunji. Google it if you want. It's just bonkers amount of rain, honestly. But yeah, Cherrapunji, a nightmare to spell, but a pretty cool place. But you don't need to learn what's on the screen, but it's just one of those little notes that you can have the same climate in a country, but each part of that country will have slight variations based on a whole range of factors. All right, not crucial, just a little bit of reminding, really. And that brings us to impacts on life. There's a few questions on page 47 that you could take notes under the headings of, or you could obviously just take your own notes. The wet season, of course, you get lots of flooding. You can see the people in that photo are just getting on with it. They're used to it, it happens every year, you just got to crack on. But of course that flooding is going to cause some disruption. It does lead to loss of life on occasion. It's super important for the rice harvest, and you could have a little synoptic link here to the primary sector, of which India has a huge percentage of people working as farmers and fishermen. But if the rice harvest didn't happen, that would cause massive impacts on the subcontinent of India. It's also relief from the heat, because the very hot dry season causes a whole range of problems, melting plastic objects, people die of heat stroke. So the wet season does properly give them relief from that. You could have a little link to the water cycle, whereby all the water stores are going to fill back up again. But because it's a season of storms, you get coastal erosion. So it's just a reminder that, of course, we are now aiming to be synoptic, which means we try to think about not just the module that we are studying, but we try to think about how does that link to all these other bits of geography. And there is a fab video that will help you with this, which I'll show you in a second. So the two YouTube clips at the top, if I've confused you, not explained myself very well, whatever, of course, contact me and say, Nikki, I don't understand this bit, or what on earth did you mean by that? And I'm very happy for people to contact me. But sometimes hearing things explained in a slightly different way by a slightly different person is useful. So I've included two YouTube clips at the top of the slide, which are essentially the same information explained differently. So that might help you. And then the bottom one, when you open that hyperlink, you're going to be like, this is so old-fashioned, and it is. It's really old-fashioned, but it is so brilliant for being synoptic, because it links coastal erosion and migration and birth rates and ecosystems, and it just kind of goes, look, all of geography is really linked together. It's 47 minutes. I'm not saying that you have to watch the whole thing, but I would really like you to dip into a few bits of it to get the sense of how living in this climate affects everything. Okay, so email me if you need to, if you get stuck, but take your notes, use the module booklet, use these video links. Okay, thanks very much, everybody.